Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be taking a look at systems of equations, just like we were doing before, and we're still going to be solving them algebraically, but this time we're going to be using a different method. So in the last lesson we were using substitution, and this time we are going to be using elimination. That's the only difference. And of course we're going to have different steps. So you can see these steps are a little longer than the ones from the last lesson, but they're about as easy. So let's go ahead and try them out. So step one, align the terms with the same degree. Since the squared term is the variable x, eliminate the y term. We don't want to eliminate our x terms because that means we're going to lose our quadratic function there. So we want to eliminate the y term. And so in this equation, you can already see they're almost lined up, but not quite, right? Let's go ahead and rewrite the line function over here. So we're going to line up our y's. Our line does not have an x squared. So I'm going to leave a space here, and then I'm going to have x and plus 6. And this step, once you get good at this, you don't really have to do this, but we're gonna do it for now, just like we did there. All right, what's the next thing we're gonna do? We're going to multiply one or more of the equations, if necessary, to have the same coefficient for y. Right now, they both have a coefficient of 1 in front of the y, so we're good. We don't need to do that. C, add or subtract the two equations to eliminate y. So hopefully now this is starting to ring a bell as to what we're actually going to be doing here. Well, what we want to do is y plus y would give us 2y, y minus y would give us 0. So we're going to subtract equation 2 from equation 1. And when you do that, you're going to be left with y minus y is 0 equals x squared, there is no x squared, so this is just going to fall down. And then we're going to have, there is no x, but it's minus x. And minus 6, because we're subtracting equation 2 from equation 1. So treat this as x squared plus 0x plus 0. And now you can see it a little clearer. What's 0x minus x? That's minus x. What's 0 minus 6? Well, that would be negative 6. And of course, this would be 0x squared, right? And x squared minus 0x squared is just x squared. And so this is why you want to line them up. It's going to help you with this step. So our equation here is x squared minus x minus 6 using elimination. Now it's going to look very similar to the last lesson, where we're going to be solving the resulting quadratic equation by factoring or using the quadratic formula to find the x coordinates. So this one, we're not going to have to use the quadratic formula. It's pretty easy, right? This is one that we can factor. And it's 3 and 2. 3 times 2 equals 6. And 3 minus 2 equals 1. And so we're going to have x minus 3, x plus 2. So you just have to play with the plus or minus signs to kind of get that to work there. And there we go. Now we have x equals 3 and x equals negative 2. And we're going to substitute the values, just like before, into the original linear equation to determine the corresponding y values. Let's go ahead and try that out. So we want to find them for our first point. So P1, what is it going to be? So x value of 3. We are going to have y equals 3 plus 6. So y equals 9. All right. So we have our first point. Let's do the second one, P2. Y equals, this time it's negative 2 plus 6. And so y is equal to 4. Okay. And this gives us our 2 points. And those points, P1 is 3 and 9. And P2 is negative 2 and 4. And if you remember, this is exactly like lesson 1 from the example 1 from the previous lesson. So of course we have the same solutions. The only difference is how we got to those solutions. In the first lesson, we did the exact same equations, substitution, and got the exact same answers, so I don't need to check them again. And this time we used elimination and still got the same answers. So whichever method works for you, that's the one to use. Sometimes you're going to be able to look at them and just know intuitively after you've practiced this enough which one's going to be easier, substitution or elimination. Okay, let's go ahead and give this one a shot. So for example 3, we're going to be solving a quadratic-quadratic equation using elimination. So this is going to look a little bit different now. Both of the equations are going to be quadratic. So this is a quadratic, we see that with the x squared, and this is a quadratic, we see that with the x squared. Let's go ahead and take a look at the steps for doing this. Well, step 1, align the terms with the same degree. Since the squared term is the variable x, eliminate the y term. Okay, that's pretty much what we're always going to be doing. Now I'm going to add a step to this. Why don't we also, while we're at it, always put our quadratics in the form y equals ax squared plus bx plus c. Why? Because that's the standard form, and if you do this, then your terms will always be aligned. So it's just, something good to do. So let's work at this one. Let's move the y over to this side. Okay, so we're going to have y equals 3x squared minus x minus 2. There we go. Let's do the same thing. We'll move the y over here and we'll move the 4 over there. So this is going to give us y equals 6x squared plus 4x minus 4. And there we go. Our terms are now aligned. Step B, we're not going to have to do. This is only if you don't have the same coefficient for y. But we can see here, our coefficients in front of the y's are both 1. So we don't have to do this step. Add or subtract the two equations to eliminate y. We're going to subtract because y minus y equals 0. So y minus y equals 0. Now you see they're aligned. So putting them in this form is going to save you some time. 3 minus 6 is negative 3. X squared. Then we have negative x minus 4, so that's negative 5x. And we have negative 2 minus negative 4, so positive 2. Okay. At this point, we're going to move on to the next step, solve the resulting quadratic equation. And there's a few ways that we've learned to do this. So we're just going to kind of do it the easy way. We're going to factor, right? So we're going to start off with the easy step, looking at what's going to come first. Negative 3x times x is negative 3x squared. This can only be 2 and 1, and they need to add up to 5. So we know that this negative 3 is probably going to have to multiply by the 2. So negative 3 times 2 gives us negative 6. And then we need to go down by 1, so we need to do that. Let's double check. Okay. Negative 3 times x is negative 3x squared. We're good. Negative 3 times 2 is negative 6. 1 times x is plus 1. Negative 6 plus 1 is negative 5. We're good. And 1 times 2 is 2. And we're good. So that did work. So we factored. Now we have our two solutions, right? So this is going to be x equals negative 1 divided by negative 3, so 1/3. And x equals negative 2 here. All right. Then we need to substitute to find our corresponding y values. So let's go ahead. When you're doing this with quadratic-quadratics, before when it was linear-quadratic, you're just using the linear one, right? Because that's the simpler equation. That's why we did that one. Now you just need to kind of look at your two equations. So here they are. Which one looks simpler to you? Y equals 3x squared minus x minus 2, or y equals 6x squared plus 4x minus 4? Well, I would say equation 1 is simpler than equation 2. So we're going to use that. So y equals 3. X, in this case, is 1/3. right? We're using our first solution. I'm not going to box it yet because we don't know. Yeah, we need to verify it first. So x is 1/3, so squared, minus 1/3, minus 2. Now this is going to be 1/3 squared is 1/9. Minus 1/3, minus 2. 3 times 1/9 is 3/9. Minus 1/3 minus 2. And this, of course, is 1/3. So 3/9 is 1/3. 1/3 minus 1/3 are going to cancel each other out. So y equals -2. And let's go ahead and just check in our calculator and make sure Mr. Emond didn't make a mistake. So 1/3 squared minus 1/3 minus 2. Does it equal -2? Yeah. Okay. And so there we have our first point. Our first point, so P1, happens when x is 1/3 and y is -2. And P2, we didn't solve for it yet, but we will in a second. That's a really funny looking P. All right, same equation, but this time -2 as the x value. All right, so y is equal to -2 squared is 4, so 3 times 4. Negative means positive. These are going to cancel out, 2 minus 2, right? So we have y equals 3 times 4, which is 12. So our second point happens when x is -2 and y is 12. Now we're going to verify the solution. Let's verify it graphically. It's just a little faster to verify graphically, especially with technology these days. So let's do that. Let's switch on over to our sketchpad and enter in our functions. So our first function is 3x squared minus x minus 2. There we go. Our second function is 6x squared plus 4x minus 4. There we go. And I can see 2 points of intersections here. So let's analyze the graph, find our intersections. One's happening right there. So that looks like 1/3 and -2. And we found that one. And I might need to scroll. Yeah, so my intersection's somewhere over there. So intersection, let's find it, -2 and 12. And there we go. So we verified it. Okay, it's your turn. So here you go. You have 2 quadratic equations here. Solve via elimination. When you're done, come back and check your answer. See you soon. Okay, welcome back. Let's take a look at the solution. So what should have happened is you put it in standard form, both of them, and then you used elimination to cancel out your y's. And you would have got 5x squared minus 40x plus 80. Now, hopefully you saw that each of these three, your a, b, and c values, are all divisible by 5. So you could factor out that 5 to get this simpler quadratic. And that can easily be factored. X minus 4 times x minus 4. And so x equals 4. Then you just substitute that 4 value into one of the equations. I picked this one. You didn't have to. You could have picked the other one. And you would have found your y value to be equal to 4. That gives you this point where x is 4 and y is 4. And to verify the solution, I graphed it here. We can see our 2 graphs look like they're intersecting at only one point. Let's drag over it. There it is, 4 and 4. That's it for this lesson. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end. And over here, you will find the next video in this unit. Keep learning, everybody. Take care.